So we're looking at distance time graphs. We'll be able to see how the linear graph concept applies to these kind of graphs. Then we're going to end up using the gradient as well too as a skill, but we need to understand distance itself, what it is, what it calculates, and then after that we're going to see how we can apply it to the actual graph. So the objectives we want to look at is deriving the average speed of a body in motion. So we want to understand how to calculate the average speed of a body in motion, which is going to be a different concept altogether. Then we want to know how to calculate the distance or the time or the average speed when two variables are given. Okay, we want to actually calculate it. And then we want to determine the gradient of a distance time graph. What that gradient means, what does it tell us, so forth. So we have different parts of a distance time graph. So if you look at this, we have this part which represents the y-axis. What can you see on the y-axis? What is on the y-axis?
Distance in meters.
Distance in meters. Excellent. So the y-axis represents distance on a distance time graph. Now on the x-axis represents what? The time. Excellent. Excellent. So I have the time. I know what the time is in seconds, and I have the distance in meters. Now, when we actually plot time against distance, we are gonna get a line that's gonna tell us how the distance was changed or covered over time. Okay, so if you look at this, after 1 second, the person covered a distance of how much?
2 meters.
2 meters. Excellent. 2 meters was covered in the first second. Now by the time we reach the 4th second, how much did we cover in distance?
8.
Alright, so we covered 8 minutes after 4 seconds. Now notice, we have here what we call constant speed. So the concept of constant speed, all that means is that you're covering the same distance over a given time consistently. Okay, so for instance, after the first second, all right, we covered 2 meters. After the second second, we covered 4 meters. By the time we hit 3, we went to 6 and so forth. So we're increasing by 2. So in essence, that constant speed here, over time we're increasing the speed by the same amount. That's what we mean by constant speed. Now, this gradient here that you see is steeper. Okay, you see how steep this is? So what this means is that relative to this one, this motion of whoever is doing this one in red is going faster than the person who is going in blue. The next feature we have is a stationary, meaning that there is no motion. So if they are at the same distance over a long period of time, it means that no motion is taking place. So that person is at what we call rest. The distance is on the y-axis. The time is on the x-axis, and then you have the gradient of that gives you the constant speed, not just any speed, because we're going to talk about average speed and then constant speed. So as we said earlier, constant speed means that we're going at the same speed over a period of time, whereas average speed is going to be something different. Okay, so I want y'all to take this down so you could understand the concept of this distance time graph. Alright, so formulas for regular calculations, that's what we want to look at. So we have average speed, which is basically the distance divided by time. So when we do distance divided by time, usually people refer to that as speed, but what that actually is average speed. So we're going to talk about that in a little bit. And then if we want to calculate the time, if we have these stuff, then the distance divided by the average speed would give us the time. And of course, if we want the distance, that's going to be the average speed multiplied by the time. So in essence, these three are the general formulas for the average aspect of speed that we're going to look at first. So we're going to do some examples on this to kind of see if y'all know which formula to use and when. What we want to talk about is the units for speed. Remember, speed is basically distance divided by time. So the first one we're looking at is m divided by s. This means meters divided by seconds. So essentially, the speed is saying the meters per second, or in other words, we can write it like meters seconds to the -1. So just to basically explain to you where this ms minus 1 comes from. So essentially, meters divided by seconds, or meters per second, can be written like this. So meters over seconds is the same thing as saying meters over 1 times 1 over seconds. So m, meters per second, meters times 1 over s is the same thing as this. Alright? So m times 1 is m, 1 times s is s. Now, this particular one here, 1 over s, another way of writing that, because s is just by itself and it's only basically s to the power of 1, okay, so think of this as s to the power of 1. We obviously don't have to write it there, but because it's s to the power of 1, so this here means the same thing as s to the power of negative 1. Now likewise, if I had 1 over s squared, I could also write that as s to the power of minus 2. So s to the power of minus 2. So if you look at this here now, that is why they just say, you know what, let's leave this m here, and next to this, since this can be written as this, we say s to the negative 1. Just to prove the point, let's do it on a calculator. So 1 divided by s. So let's just say s was 2. So in other words, 1 divided by 2 is 0.5. So if you had to write 1 over 2 in that special form, 1 over 2 would turn to, since this is 2 to the power of 1 basically, it's going to be 2 to the power of negative 1. Now, when I go over here now, I could say 2 to the power of, so this is the power of minus 1. Look what my answer is. You guys notice how my answer is the same thing as 1 divided by 2? So 1 divided by 2 is 0.5, and 2 to the power of negative 1 is the same answer. So in essence, that's basically how we come up with this. So this is just an alternative to writing this. I said all of that just to say that this here may look strange, but it is valid. So you may want to take this down for support if you want, just for your knowledge, but it's not something necessarily something that you see often in maths, but you do see it in physics for sure. So the second one now, same concept, speed, kilometers per hour, also written like this. So that's basically, again, distance, which is kilometers, divided by hours, which is time. And then our famous one that we usually have is speed, miles per hour. Now we know that this is usually American standard, so they don't do anything fancy like how the metric system rather would be. So they just leave it as this, even though technically it would, you would think that it would be mi for miles, then after h to the negative 1. Essentially, they just say, you know what, we're going to use it as an abbreviation as opposed to a unit. So this here uses the unit. This here now basically uses an abbreviation. So each of these letters mean something. So m means miles, p means per for this line here, and h means hour. So literally, they use the abbreviation to represent miles per hour. But because our education system basically is under Britain historically, we're going to be using the metric system, which primarily uses meters per second or kilometers per hour. Alright, you guys should have that down. So let's look at some questions. So the first question, it says, a man was traveling for 40 hours, of which he covered a distance of 8,000 kilometers. What was his average speed? Now, something I should note is that when we are actually calculating this stuff, we need to ensure that our units match. So, for instance, if I have meters, I would expect to use seconds. All right? Likewise, if I have kilometers, I would expect that you use hours. Alright, so you wouldn't say kilometers per second or meters per hour. You would typically say kilometers per hour. So you try to work out what the kilometers are and compare with the hours or meters with the seconds. So just bear that in mind. So let's see what y'all come up with this first question. As soon as you get your answer, let me know. Remember, in this context, it's very important to have our units established. Remember that, guys. Alright, so let's go through this here now. So we have the speed that we are trying to calculate, and this is the average speed. So let me explain what the average speed is, okay? Now, the reason why we call it average speed. Yes, this man covered 8,000 kilometers in 40 hours. Now, the reason why we call it the average speed is he may not have been going at the same speed every time. So maybe he was walking fast, then he stopped, talked to a friend for a bit, then he started walking fast again, then he stopped, then he decided to run, then he walked. At each moment that I just described, his speed is gonna be different. So we cannot say he had a constant speed throughout the whole journey. All right, so that's why we refer to it as the average speed, because his speed would have been changing over time. Maybe one time he stopped, maybe one time we don't know. That's why we refer to this as average speed. So we know that speed is in kilometers. We have kilometers here, and we also have hours. So both of them were in the units that we expected to have together. Remember, once it comes to speed, we know that kilometers per hour is 1 of hours and meters per second. So therefore, the fact that I have hours and kilometers together, I do not have to do any conversions. So I can use my 8,000 and my 40. So then now, because speed is distance over time, I can just divide these two and I'll get 200 kilometers per hour. All right, excellent work on this. I saw that you all did lovely on this. Just remember the units. So we either put it as kilometers per hour, as like this with a slash, or we put kilometers, and then if we put the hour, we put -1 as the power. All right, let's try the next one. Let's see how you guys do on the next one. So question 2. A woman was flying a plane for 300 seconds, of which she covered a distance of 12,000 meters. What was her average speed? Again, we do not know if she was changing speed or what. Maybe she was going fast, then she was going slow. There's so many dynamics to take into consideration. So we know that because we are unaware of whether she did the same speed throughout, we have to refer to it as an average speed. All right, the average speed. So later on, when we get into the graph aspect of this lesson, we'll basically see a visual representation of what I mean when I say over time the speed changes. So try this one, you know the routine. All right, I see we punching with this. All right, next question. Be very careful with this. Really look at this one. I got a hidden trick in this one. It says, if a distance of 300 meters is covered in a minute, if a distance of 300 meters is covered in a minute, what is the speed in meters per second? All right, so what do we have here, ladies and gentlemen? All right, so we want to calculate speed. So obviously we're looking at the average speed, which is distance over time. Distance over time. Now, one of the key things that I've noticed here is that we want it in meters per second. So our distance is already in meters. It's given us 300 meters. Now I want my time to be in S, which is seconds. But the time they gave us is a minute. So as a result, I have to convert a minute into seconds. How many seconds do we have in 1 minute?
60.
60 seconds in 1 minute. Excellent. So in essence, I would head and say 300 divided by the 60, which is that minute, to get my answer of an average speed of 5 meters per second. 5 meters per second. All right, let's look at the next one. Take this into mind. What we're doing here, it says if a distance of 5.4 kilometers is covered in 70 seconds, what is the speed in meters per second? Let's see what y'all get for this one. If you get a decimal, do it to the first two. All right. So let's check this out now. So with this one, what is the issue that we have here? We wanted in meters per second, but what did they give us? They gave us what? What did they give us? Kilometers. Okay. So because of that, since we want meters per second and we already have time in seconds, we need to convert this to meters per second. Now remember, 1 kilometer is equal to 1,000 meters. That's what the K stands for. A kilo is 5,000. Okay, so this means 1,000. This here is basically 5.4. Basically means 5.4 thousand meters, which is essentially 5,400. Okay, so we say 5,400 divided by 70. All right. So 5,400 divided by 70, which gives us 77.14 meters per second, because we wanted it in meters per second. All right. And because 1 kilometer is 1,000 meters, all we had to say is 5.4 kilometers, multiply that by 1,000, which gives us 5,400 meters. All right. So a few more questions like this. Then we get into the graphs. A man traveled at an average speed of 7 kilometers per hour. If he was traveling for 2 hours, how much distance did he cover? So let's think of this literally, right? If I'm telling you that I'm traveling 7,000 kilometers every hour, so that means after the first hour, I would travel 7 kilometers. Then when the next hour go again, what would you expect me to cover? Another 7 kilometers. Okay? So I want you all to think about this question and see what you come up with. Alright, so let's look at this. We are trying to calculate distance. Now based on what we learned, distance would be something that is part of this formula, average speed. However, we have to rearrange, because if we're looking at the formula, average speed here is equal to distance over time. We have the distance over time. We have the average speed in kilometers per hour, and we have the hours that we require, which tells us that once we work this out, we'll get the kilometers per hour. So the kilometers per hour is 7. So we say 7 is equal to the distance, which we are looking for, over time, which is 2. So what I'm going to do is some basic calculations here to work it out. Okay, so essentially I'll end up multiplying to get distance. So I'll have here 7. To get rid of this 2, multiply both sides by 2. So these basically cancel out. That's why we are left with 2 times 7 to get distance. But if you remember our equation from the previous slide that we had some time back, we had a formula that said distance is equal to average speed multiplied by time. So in case you forgot, this is it right here. Good night. What's up, you good? So 7 times 2 is 14 kilometers. So basically this is the same as 14,000 meters. So 14 kilometers would be our answer. The equivalent in meters would be 14,000 meters. All right. So we got 4 more questions on this section, and then we'll get into the graphing aspect. So I want you to look at this. A woman was swimming at an average speed of 19 kilometers per hour. If she was traveling for 3 hours, how much distance did she cover in meters? Now notice in this question it's very specific as to what units they want the answer to be in, whereas for the previous question they did not specify, but they're very specific in this question. Take a look at it and let's see what you get. Alright, so for this one, same concept. We have the average speed, we also have the time, so let's just replace the average speed with 9 and the hours with time. So now to get distance by itself, we're gonna essentially do what we call cross multiplying. You guys know this here. So it says 9 is basically over 1 is basically a fraction. So we could say 9 times 3 would be equal to distance times 1, which is just distance. So essentially distance is equal to 27. Now it says we have 27 kilometers, but we want to have it in meters. So essentially we're going to say distance is equal to 27 times 1,000 to get our final answer in meters. Question 7. Mr. Quick drove to work at an average speed of 120 kilometers per hour. If he was traveling for 40 minutes, notice, ladies and gentlemen, this is a very interesting one. How much distance did he cover in kilometers? Notice what we said, 40 minutes. You have to do something a little special here. Let's see what you come up with. This one should rackle your brain just a little bit. Now notice, they gave us kilometers per hour, but the time they gave you was in minutes. How can we represent minutes as hours? Alright, so let's go through this one here now, right? So this particular one, it gave us minutes. So I need to convert minutes into hours. Now the thing is, 60 minutes is 1 hour. And as you can see, I do not fully have 60 minutes. I only have 40. So therefore, only a portion of that hour would have been achieved. So therefore, if we had 40 minutes, how do we convert that? So if we have 60 minutes and we were to put that over 60 minutes, because remember, in order to find out the number of hours, I need to do the minutes divided by 60 minutes. So if I had 60 minutes and I divide that by 60 minutes, that's essentially 1 hour. Now, if I have 40 minutes, I want to convert it to hours. I divide this therefore by 60 minutes. So what that would give me is essentially the hours. Okay, so this is roughly 0.67. Okay, so if we want to work out what the time is, we do that, multiply the distance by the time, which is basically 40 over 60, which represents hours. Remember, this here represents hours, okay? 40 over 60 represents that time. 40 over 60 hours. Because it's a proportion of an hour, not a full hour. That's why it's a fraction that has not even passed 1. So this is about 0.67 if you divide this in the calculator. So 120 times 40 over 60, it gives me 80 kilometers. 80 kilometers. So therefore, my answer is 80 kilometers. So if you did not have this, you can take it down, because this is a good one to have. Let's see what you guys come up with this one. Alright, so for this one here, we want to calculate the distance. So we know that the average speed is equal to distance over time. And essentially, if I substitute the distance, 3,000, and the average speed, 6, and says, that over time, which is what we want, if we was to do the same concept of cross multiplication, so just to show you the mathematical side of it, you can also use the time formula. There is a time formula, which would be the distance divided by speed. But just to show you the mathematical concept, so 3,000 over time, or t, so we cross multiply. So 6 times t is 60, which is equal to 3,000 times 1, which is 3,000. So then now what we can do is divide both sides by 6. Okay, we divide both sides by 6 and we'll end up with t is equal to 500 seconds. So time is 500 seconds. Alright, one more like this and we start to look at the graphs. So Sue drove for 20 meters per second over a distance of 60 kilometers. How long did she take to cover this distance in seconds? Remember, we're working with seconds and we have a speed of 20 meters per second. So this meters per second already has a second included. But this here says 60 kilometers. Let's see what y'all will do with that. Alright, so with this one here, we need to convert this 60 into meters. So 60 kilometers would essentially be equal to 60 times 1,000, 60,000 meters. Now that I have that, it's like we are saying, I know the average speed, which is basically 20 meters per second. And I also know the distance, which is 60,000. So now, like what we did earlier, you can say 20 over 1 since it's a fraction, which is equal to 60,000 over t, which is time. So then we can cross multiply. So the 20 times the t, which is 20t, and that's equal to 60,000 times 1, which is 60,000. So 20t is equal to 60,000. To get the t by itself, we divide both sides by 20,000. Once we do that, we will get our final answer, which would be 3,000. So 3,000 seconds would be our answer. We have Connor, who had a journey from town A to town D. Now, if you look on the y-axis, you would notice that we have distance. On the x-axis, we have time. So we know this is a distance time graph. So we have phase 1, as you can see here, phase 1. This here would be constant speed, because notice it's increasing by the same amount over time. So if this is 0 and this is 10, we know the middle of here is 5. So it says the first 5 seconds, it covered 100 meters. And then for the next 5, which put us to 10 seconds now, he covered another 100 meters. So that's how we got 200 meters coverage in that particular time. Now, who can tell me what was happening in phase 2? What happened in phase 2? Just visualize it. So imagine you travel 10 meters, then you stop traveling 10 meters. You was just there, and then you just remain there. Then later you move. What would you say?
Is he in the same area?
Exactly. You're in the same area. They stop. We are not moving. We are at rest. All right. Lovely. So that means during that time period, 10 to 30, Connor was at rest. He was not moving. Okay. He was not moving. All right. So let's go through this phase by phase. I want y'all to understand what's going on here. So the first question is, what was the total distance traveled for the entire journey? So I want you guys to try to answer that. Then we'll go through it together, and then I'll ask you the next question, and we go through it phase by phase. All right. So what did you guys come up with? What was the total distance traveled based on this graph from town A to town D? What was the total distance traveled? 500. Because if you look at it, it started at 0, climbed to 200, stayed there for a while, then went all the way here to 500 meters. So for question 1, answer is 500 meters. Next, how long was the journey? How long was the journey? Who can tell me how long was the journey? Correct, 60 seconds. 60 seconds. Now, if you look at this visually, this is showing us changes in speed. Remember, these lines on a distance time graph, these lines show us speed. Gradients of these lines show us the numerical value of the speed, but if we're looking at the lines itself, that gives us an idea of what's happening with the speed. So in this case, you can see we have it increasing, but this one here was not as fast. So phase 3 was not as fast as phase 1. Look at the steepness. Phase 3 is not as steep as phase 1. So those phases essentially were going at different speeds. Now phase 2 was not moving at all. So in this whole journey, there were 3 different speeds that were taking place. Now this is why we refer to our good friend as average speed when we have the overall distance and the overall time, because we do not know how quick it was going at any given point. That's why we call it the average speed, because we expect that more than likely, unless otherwise stated, that the entire journey with different phases and different speeds. That's why we use the average speed. So with that being said, what was Connor's average speed? How do we work that out?
Distance over time.
Distance over time. So essentially, what we would be doing is the overall distance, all right? The overall distance, which is 500, divided by the overall time, which is 60. So 500 divided by 60 would give us our average speed. Okay, so 500 divided by 60. So then we're left with 8.33 meters per second. Now the next question, what was the constant speed in phase 1? Now, in order to do constant speed, what we need to do, guys, is pick 2 points on the graph, and then this is where we go back to our linear equations. What is the coordinate here? This dot here, what is the coordinate for here? 0, 0. What's the coordinate for here at part B?
10, 200.
10, 200. Okay, so that's the coordinate there. So with these 2 coordinates, we can answer question 4. So we have 2 coordinates, 10, 200, and we also have 0, 0. So what does that mean for us? We have a x1, y1, and we have a x2, y2. Let me put this on the other one. x1, y1, and then we have x2, y2. So then I could say y2 minus y1 over x2 minus x1. So I can replace this y2 with 200. So 200 minus y1, which is 0, over x2, which is 10, minus 0. And this would give me these values. So 200 take away 0 is 200. And then 10 minus 0 is 10. So therefore, that will be 200 divided by 10, which is 20 meters per second. Now, how did I get meters per second? Remember, the y2 take away y1 represents the y-axis, which is basically distance, And then the x-axis, x2 take away x1 represents what? Time. So it's literally like saying distance, and this represents time. And what is distance over time? The speed. Remember, this first one represents m on this axis. So m over, and on the x-axis, x2 take away x1, s. So that's how I got my units down here. All right. So meters per second, y2 take away y1 over x2 take away x1 was the distance over time. All right. Let's look at phase 2. So automatically, I already know what phase 2 should be. What should be the gradient of phase 2? If you look at this, we have 30, 200 represents this point here. This point here is 10, 200. So that's phase 2 we're looking at. So phase 2, if I write down these points, that's the only way I can get the gradient. So 30 is x1, 200 is y1, 10 is x2, 200 is y2. Okay, so now we have y2 take away y1. So y2 minus y1 over x2 minus x1. Alright, so that's a gradient. So what's y2? y2 is 200, so we have 200 minus 200 over 10 minus 30. So then I'll be left with 0 over negative 20, which does not matter because anything 0 divided by a number would always give us 0. So that's 0 meters per second. Hope you all taking note of this. Notice what's going on here. You see how the speeds are different? That's what we realize. Now the last one, I want y'all to work out this one, the constant speed. So now that I'm saying constant speed, I'm saying that look, we're increasing at the same speed. The only way to work out this constant speed from the graph is to calculate the gradient of the distance time graph. So this coordinate here is 60, 500. You all know how to calculate the gradient. Let me see you calculate the constant speed of this distance time graph, or in other words, calculate the gradient phase 3. Now the routine, once you get it, you send it to me. What do you all get? What do you guys get for the gradient? 10. What do you get?
10.
Lovely. Anybody else get 10?
Yes.
Wonderful. Wonderful. So if we had this, remember, we could consider this here as x1, y1, x2, y2. So if I was to do that in the formula one time, 500 minus 200. Remember, we always use the y's at the top. So I'm using this formula here, y2 take away y1. So 500 y2 take away 200 y1 over x2. So x2 is 60. So 60 minus x1, which is 30. And that's going to be equal to 300 over 30, or 10 meters per second. So guys, notice how for every phase that we had, notice how the speed changed. So this constant speed was 20 meters per second. So he stayed at 20 meters per second for 10 seconds. And then he was at 0 meters per second for the next 20, from 10 to 30, which was the next 20. And then after that, from 30 to 60 for the next 30 seconds, he went at a speed of 10 meters per second. So that's important to note. That shows you that over a journey, someone does not always travel at the same speed. Okay? So, first thing says, the journey below is of a cat to its home. So this cat is going home. Let's see how y'all calculate this. Now be very careful, be very careful. Notice that there are two differences here. We have average speed and constant speed. Remember what the average speed is. It's like the overall distance, but the overall time in that particular area. And then the constant speed would be the gradient. Alright, let's see what y'all come up with. We have kilometers this time per hour. Alright, so let's look at this here now. So it says, how far did the cat travel to reach from A to C? So from A to C, we have a distance travel of 14 kilometers. Now, for the average speed, in order to know the average speed, we need to know the entire time taken to complete the journey. And based off of this, we went as far as 16 hours. We already have the distance. So for part 2, since it's the average speed, that means we want distance divided by time. So therefore, our average speed would essentially be the distance overall, which is 14 kilometers, divided by the overall time, which is 16 hours, and that gives us our speed. So then we'll have 14 divided by 16. So essentially our speed is 0.875 kilometers per hour. Alright, so part 3. It says, what was the constant speed from A to B? So now we need to know the constant speed from A to B. So I know it's tempting to just look at this and say, oh, I'll take this and this number and just divide them. But guys, that's gonna only work because we're coming from the origin. We're coming from the origin. If we were to have this graph starting from 2, trust me, you would not be able to do it that way. So that's why it's important to practice y2, the coordinates having coordinates, so in this case 10 10, and then here is 0 0. So then we label it accordingly. So then we say this is x1 y1, this here is x2 y2. So therefore the gradient would be equal to y2 minus y1 over x2 minus x1. So therefore that would give me 0 take away 10 over 0 take away 10, which is essentially negative 10 over negative 10, and negative 10 divided by negative 10 is 1. Now remember, this top y2, y1 represents km, so that's km, over x2 take away x1, which represents time in hours, so hours. So clearly, if this is kilometers per hour, we need to put it as the units here. So that is the answer for number 3. Now number 4. Who can help me with number 4? How many hours was the cat at rest? How do we know that a cat was at rest? Where is the cat at rest?
From B.
From B. And how did you know that?
Cause I mean it'll show. It'll the line on the graph ain't going up, so it's just going straight. It stopped there.
Excellent. So it's flat and just showing like no movement at this after this distance. That's how we know at that point is when it's at rest. So from here to here is essentially 10 hours to 12 hours. So that time difference would give us how long it was at rest, which is essentially 2 hours. All right. Now, number 5. How many hours was the cat in motion? So the cat had to be in motion during what times?
From A to B and from like after rest to C.
So it would be from A to B. So A to B is essentially 10 hours. Okay. And then if you're looking at it from here now, from here to here, so 12 to 16. How many hours is 12 to 16?
4.
Lovely. So this here is also B. So from B to C was 4 hours. So in total, it was moving for 10 plus 4, which would be 14 hours. Another way you could have done this is, the overall was 16, and then I just minus the time it was not moving. So if it was not moving for this time, which would be 2 hours, that means it had to be moving for the other time. So 16 take away 2 is 14 hours. Alright, so guys, that's basically how we do distance time graphs. We have average speed and constant speed. Remember, to get the average speed, we have the overall distance divided by the time. But for constant speed, we have to pick points from the graph to calculate the gradient, which represents the speed on a distance time graph. Very, very important. So this is something to go over. I have an activity for y'all to work on, and I really would like y'all to work on it tomorrow. So I'll send it to you in the chat for you to work on. Okay,